Hi students, and we're going to be taking a look at problems involving right triangles. So this is an interesting problem to look at first because notice that there's no right triangle that we see right away. Instead, we have a right trapezoid. So let's see what we have. We've got this length is 14, this length is 8, and this length 8, and we're looking for angle X and angle Y. So our first step here is we're going to use some of our skills from grade 8 and grade 9 geometry. And first thing we're going to do is I'm going to take a line from this vertex here, and I'm going to drop it straight down at 90 degrees. So notice what kind of shape this breaks it up into. Right now I have a square, and I've got a right angle triangle. So let's take a look at some information that we can add here now that we've dropped down this line. Well, a good question to ask would be, well, what's the length of this line? Well, if this is a square, then this length is going to be 8. Similarly, if this is a square, this length here is going to be 8. And because the whole length is 14, if this is 8, this length here has to be 6. So now we're going to use SOHCAHTOA in order to help us solve for x. So notice that we're looking for an angle. Anytime you're looking for an angle, you're going to use your inverse function. So with respect to x, let's take a look here. With respect to x, the side length of 6 here is opposite, and the side length of 8 is adjacent. So which function here uses opposite and adjacent? Well, that's tangent. So what we're going to have is the angle x is going to be equal to the inverse tangent of our ratio 8 over 6. So let's punch this into the calculator and let's find an approximation to the nearest whole degree that we're going to get. So once we punch this into our calculator, we can see that to the nearest degree, this is equal to 53 degrees. So the question now is, well, how can we solve for y? Well, notice that y is an angle that's shared between two different angles. We really have this angle here plus, plus this angle in here. So we already know that this angle here is 90 degrees because it's a part of a square. So what we're really looking for is this portion. Okay? So I'm going to call this portion here angle Z. Now we know that angle Y is going to be equal to 90 degrees plus angle Z. So let's take a look at the next page here, and let's just redraw our triangle and solve for Z. So right now we've got our triangle all set up as the way it was before, and we're just looking for angle Z here. So let's name the sides with respect to Z. Well, 6 is going to be our opposite side, 8 is our adjacent side, and here's our hypotenuse. So again, we're going to be taking a look at SOHCAHTOA. So I'm looking for an angle. That means I'm going to use an inverse function. But which inverse function? Well, the opposite and adjacent side are known, so once again, I'm going to be using the inverse tan. So to find out Z, well, angle Z is equal to the inverse tangent of opposite over adjacent. So in this case, it's 6 over 8. And let's see what we get when we punch this into our calculator. So what we find is that Z is equal to approximately 37 degrees. Well, if Z is 37 degrees, remember that that's this portion right here. So we want to find out all of Y, so we're going to do the value of Z plus 90. So let's throw that in here. So we're going to get Y is then equal to 90 degrees plus 37 degrees. So we get Y is approximately 127 degrees to the nearest degree.